All right. Okay, so I just saw this in my news feed. I don't know anything about this, okay? But this sounds cool. We're getting into science here. Ghostly mirror world might be cause of cosmic controversy. This is from phys.org. Let's read. Okay, so I don't know what this is. I've never. Okay, so I'm gonna read. We're learning together. We're learning together. New research suggests an unseen mirror world of particles that interacts with our world only via gravity that might be the key to solving a major puzzle in cosmology today, the Hubble constant problem. So this is like some Stranger Things or Silent Hill shit. I'm in. The Hubble constant is the rate of expansion of the universe today. Predictions for the rate from cosmology's standard model are significantly slower than the rate found by our most precise local measurements. This discrepancy is one that many cosmologists have been trying to solve by changing our current cosmological model. The challenge is to do so without ruining the agreement between standard model predictions and many other cosmological phenomena, such as cosmic microwave background. Determining whether such a cosmological scenario exists is the question that researchers, including Francis Yan Syracine, an assistant professor at the Department of Physics and Astronomy at the University of Mexico, Fei Gee, and Lloyd Knox at the University of California, Davis, have been trying to answer. Let's read more. According to NASA, cosmology is the scientific study of the large-scale properties of the universe as a whole. Cosmologists study concepts such as dark matter and dark energy, my favorite Yu-Gi-Oh card, and whether there is one universe or many. The goddamn many worlds theory we're in, sometimes called a multiverse. Cosmology entails the entire universe from birth to death, with mysteries and intrigue at every turn. Now, Racine, Gee, and Knox have discovered a previously unnoticed mathematical property of cosmological models, which could, in principle, allow for a faster expansion rate, while hardly changing the most precisely tested other predictions of the standard cosmological model. They found that a uniform scaling of gravitational freefall rates and photon-electron scattering rate leaves most dimensionless cosmological observables nearly invariant. There's a lot of words here. I don't quite understand them, so let's read in. Basically, we point out that a lot of the observations we do in cosmology have an inherent symmetry under rescaling in the universe as a whole. This might provide a way to understand why there appears to be a discrepancy between different measurements of the universe's expansion rate. It's a goddamn mirror world. This is like Silent Hill. Goddamn Jacob's Ladder shit. The result opens a new approach to reconciling cosmic microwave background and large-scale structure observations with high values of the Hubble constant, H0. Find a cosmological model in which the scaling transformation can be realized without violating any measurements of quantities not protected by symmetry. This work has opened a new path toward resolving what has proved to be a challenging problem. Further model building might bring consistency with those two constraints not yet satisfied. The inferred primordial abundances of deuterium and helium. We're getting into science here. I'm going to be honest, I don't quite understand what they're trying to say yet. If the universe is somehow exploiting this symmetry, researchers are led to an extremely interesting conclusion: that there exists a mirror universe very similar to ours, but invisible to us, except through gravitational impact on our world. Such mirror world dark sector would allow for an effective scaling of the gravitational freefall rates while respecting the precisely measured mean photon density today. It's a goddamn mirror world. In practice, this is a quote, the scaling symmetry can only be realized by including a mirror world in our model, a parallel universe with new particles that are all copies of known particles, said Sire Racine. The mirror world first arose in the 1990s, but has not previously been recognized as a potential solution to the Hubble constant problem. This might seem crazy at face value, but such mirror worlds have large physics literature in a completely different context, since they can help solve important problems in particle physics. Explains Sire Racine. Our work allows us to link, for the first time, this large literature to an important problem in cosmology. I'm in. In addition to searching for missing ingredients in our current cosmological model, researchers are also wondering whether the Hubble constant discrepancy could be caused, in part, by measurement errors. While it remains a possibility, it is important to note that the discrepancy has become more and more significant as higher quality data has been included in the analysis, suggesting that the data might not be at fault. Basically, we're developing new ways of gaining data, and the data that we're gaining is not congruent with what our presupposed understanding of the universe is. That's essentially what's going on as we are developing more and more and more precise instruments, like the James Webb Telescope, for example, is doing a lot of cool stuff right now. As we're developing a lot of these more precise instruments, we're realizing, oh shit, we don't know fucking jack fuck about goddamn particles and quantum entanglement and the mirror world and all that shit. So I'm in. Consider me in. Let's make a movie based on that shit. Oh wait, they already have. All right. In addition to searching for missing ingredients to our current cosmological model, researchers are also wondering whether the Hubble constant discrepancy could be caused in part by measurement error. Oh, did I already read that? Okay. It went from 2.5 sigma to 3, and 3.5 to 4 sigma. By now, we are pretty much at the 5 sigma level, said Sire Racine, whom I've given 4 voices for in this article. That's the key number, which makes the real problem, because you have 2 measurements of the same thing, which, if you have a constant picture of the universe, should just be completely consistent with each other, but they differ by a very statistically significant amount. That's the premise here, and we've been thinking about what could be causing that, and why there are measurements discrepant, ? So that there's a big problem for cosmology. We just don't seem to understand what the universe is doing today. I'm in. The goddamn mirror world. So we're learning together. We're reading articles together as a group, folks. We're learning about science together. So there you go. I don't have anything to say. That's just interesting to think about. Let's ponder the universe, y'all.